can find out. This is another temperature device. This is a temperature transmitter. This will tie into the LCP and it's tied into the PLC. This is what tells it, the PLC, what temperature the inlet air is at. I'm pretty sure your upper limit on air will be 120. I don't think it ever gets that hot here. That shouldn't be an issue. I'm not sure what the cold limit is set up on yours. I'm sure the weather would have been taken into account here. I know you have winter. I've been here in winter before. This is a surge switch. Back to the surging. This switch is pretty simple. This is where the air would be coming into the blower before the turbine. So this is kind of what you consider your suction side. You have simply a pipe tied in and a proximity switch. And inside of this metal casing here, there is a disc. And this disc sits flat. And under normal operation, there'll be a slight amount of vacuum in this chamber, which will keep that disc sucked down to the pipe. If you have a situation where it surges, you're going to have pressure on your inlet. That pressure is going to blow that disc up. It's going to trip the switch and it's going to shut everything down, which is what you want it to do, because if it's surging, you want it to shut off. This is a maintenance item, and it's one that you're going to find with the enclosures there, it's going to be kind of hard to get to. I don't know who's got the longest arms, but that's who's going to want to be getting in there. I could get to it yesterday, but that's about all I could reach. Or a small guy that can just crawl in there. What you want to do is probably about every 6 months is to take some brake cleaner or another non-residue solvent and loosen this nut, take this whole switch assembly off, spray some solvent inside of here, shake it up, make sure you can hear it rattle, hear it move around. Make sure that when the disc is up against this proc switch, the switch does change states. That switch sitting there as it is, that disc will get stuck to the pipe eventually, and it will quit working after a while. All right, we saw the variable diffusers in the video, which are spaced all around the perimeter, controlling the air that goes out. They are all tied by a large, I don't know the proper word to be, large metal washer, so to speak, that goes all the way around. This arm goes in through the shaft, moves a cam that moves this arm around. That arm in turn moves all the diffuser blades in and out. This part you will see is going to be on, well, you can, looking at the blower from the front would be here, would be on the right side of the blower. This is a simple electrical actuator. You have the closed limit switch, an open limit switch, the actuator itself, and a scale. In the service screen, there's a way to calibrate these. Usually, the only time you should need to calibrate them is if you have a power failure. You would want to go down before you start this blower. If it's from a power failure, you'd want to recalibrate this. When you hit the calibrate, and I'll show you where to do it. when we start going through the screens, the control screens. This is going to open up fully. It's going to come down until it finds the full open limit switch. Once it finds that, it will go back up until it finds the close limit switch. When it's found both of them, it knows where the low point and the high point are at and sets them accordingly.
How long does that take?
Calibrate them?
Yeah.
Oh, I'd say about 3 minutes probably. They're not the fastest moving things in the world, but 3-4 minutes. Where these switches are set, they're set. So if you ever have one come off or something, you don't know where to put it back. They're set so that this will stop at a minimum position and a maximum position. And those positions are they're in the PLC. I can tell you what they are right now. The variable diffusers will go from 2 to 11. It's moving. The inlet guide vanes go from 2 to 10. So if you were to lose one of these switches, and it probably will happen, we've lost 2 already just from people climbing around. Usually you can get them back in the same spot, but if something were to happen where you would lose where this goes, you would take this actuator arm off, move it to the side so you could move this arm by hand, and then you could move that arm so it was at the position that you want, 2 for closed. Hold it there and you can set your limit switch in place at that time. The same with the full open. Move it down to 10 or 11, to 11 if it's the VD, and then set the switch. The VD arm itself, this is the shaft that goes through the inside. It has this timing mark. It's put in with a chisel. This is so in the event that this arm ever slips on this shaft, you'll know it. And what you'll need to do is to loosen it, move it back into place, and retighten it and torque it. There's a torque value for that, and as it says here, that is listed in your O&M manual. I believe yours is 158 foot-pounds off the top of my head. We don't tighten it more than that. This is the reason that there is a torque for this, is in the event that something should happen, that those VD blades are not free to move. If something jams them or something restricts their movement, we want this arm to slip on this shaft rather than wrecking parts. Moving back from the front, we have vibration probe and an RTD, resistive temperature device. There, on your blower, there is an X and a Y sensor on the high-speed shaft. The high-speed shaft being the one that the impeller is on. There's also a thrust bearing position sensor. Those 3 are going to detect if you start to have a bearing failure and let you know ahead of time enough that you can arrange for maintenance, schedule a visit from us, whatever needs to be done. Temperature probes, similarly they watch the temperature, make sure you don't have any bearing issues. Here now we're showing the other one had the X, here's the Y, and your thrust bearing temperature sensor comes in, from the top somewhat. The thrust, that's the temperature, the thrust position sensor for the bearing comes in from the back here. The X and the Y namely watch for movement. They're set to a little tighter parameter. The thrust bearing will allow a larger range of movement. As you vary the output of this blower, the impeller will change positions. As you ask for more air, it's going to move more into the thrust bearing. So it's not necessarily the number on the thrust bearing. You know, it may move from 0 to 5. You're not looking for that. What you're looking for is while it's running, if it moves in and out. On the lower side, we have slow speed shaft. As I said before, that's also called the bull shaft. You can see here the motor comes in. Behind this yellow cover is our coupling. Into here to the bull gear. The high speed shaft would be up here. We don't have the bearing position sensors on the low speed. We do have the temperature monitors. So this is the thrust bearing monitor, Z vibration as they're calling it. Behind this would be your thrust bearing and a counter thrust bearing, and then the X and Y bearings. Here we have a coupling guard, and it states it guards the coupling. So if you guys will ever get into this, should you need to replace the motor or for some reason need to uncouple the blower from the motor, this is the coupling that you would have to remove. There's one thing about this picture that I don't like. They call this a shim pack. The elements, let me first start just the simple elements. I'm sure most of you guys know this. You know, you have the hub, you have the spacer itself, and in between those is actually it's more like a flex plate, and it allows for anger and offset deviations between the motor. It's not a shim pack, and if you do take this apart, it's not good anymore. You have to replace it. What I will do while I'm here, in fact tomorrow I'll be doing this, is aligning the motor to the blower. If you would ever have to replace the motor, you would have to do the same thing. You'd have to realign the motor to it. We want a spacing between the motor, the face of the motor coupling, and the face of the blower coupling. Inside, in between, you want a spacing of 9 inches, plus or minus 15,000ths of an inch. That's called out in the O&M manual if you ever need to look it up. If this distance does not fall in that, move the motor to get that distance. If it's too close, move the motor back. If it's too far away, move the motor in.
Will the temperature affect that?
No, I don't believe so. Not enough that you need to worry about it. Looks like we're going to talk about the oil system for a little bit now. Blower, the bottom part of the skid is actually the oil reservoir. It holds 165 gallons. The type of oil, there's a whole list of manufacturers who you can get your oil from. We don't care who, as long as it meets the specifications. And those, again, we found in the O&M manual. As far as oil maintenance, replacement, our recommendation is that at 500 hours, you change out the oil.
Wow.
After that,
Are you guys changing it to first 500?
we don't normally do that, no.
Most of the oil, that's what I'm Maybe they will.
Sorry?
Walsh, we already got the oil, and they took the oil, so.
I believe Walsh is gonna change it at 500.
Right.
Okay.
How many days?
After you've changed it at 500,
Couple weeks.
21 days, we recommend a regular oil analysis and use your oil analysis to determine when you need to change it again. Okay? The frequency of that, I believe, is quarterly. You got, as this indicates, this is where you check, it's got a dipstick, the dipstick has a hole, that's where you'll check your level. There is,
How big's that hole? That's the good size?
probably about like that.
How easy is this, that drain, when you got a draining oil, I mean, it's come off.
We'll have a picture of that here in just a
5
second.
gallon pails, are you doing,
You should be able to hook a hose to it, I believe.
been running into a empty 55-gallon drum or something? or-
Yeah, I don't know, or if you'll need to get, if you have, I don't know if you'd have the elevation to just drain at gravity. You might have to get a pump. But the drain's on the side here,
Yeah.
just set up with pipe, so.
We'll figure it
We also have a temperature transmitter. We do monitor the temperature of the oil in the reservoir. And if it were to get too high, the system would shut down. Pretty simple. We got a breather, a level sensor, so if the oil level gets too low, it won't run. And this is your auxiliary oil pump. As long as I'm on oil, I should probably cover this a little better. As I said before, when you push the start button, the auxiliary oil pump's gonna run for 120 minutes for prelude. Seconds, sorry. When you shut it down, it's also gonna run for, I think it's 240 seconds at some amount of time. Just to make sure that, when you shut this off, it's not gonna just stop. There's a lot of mass, it's gonna wind down. Make sure that your bearings stay lubricated while they're moving until the motor is completely stopped. When you press the start button, the auxiliary oil pump is going to start to provide this pressure. And there's two paths for oil lubrication from as far as how we deliver the pressure. Once the blower is started and it's up to speed, there's a mechanical oil pump inside the blower that's going to take over. And after, I don't remember the exact amount of seconds, but after, I think, after a small period of time, once the blower is started, the auxiliary oil pump will shut off. And they are checked valve. Both systems pull the oil out of the sump, one through the electric driven pump, one through the mechanically driven pump. They both go through a check valve and then to the main oil system. From that point, the oil's going to go to your heat exchanger, which is where it'll get cooled. In your guys' case, that's cooled by water. And there's a water solenoid that'll open and close, and there's also a temperature regulated valve.